Okay, in this recording, we're going to talk about how to draw in a math context. So, this is an important tool. It's an important part of being able to learn math. For one thing, there's a symbiotic relationship with understanding the geometry of a given problem. So, in particular, not only is it true that what you understand about what the figure looks like will help you draw it, but being able to make a reasonable drawing will also help you to get a better understanding of what the figure looks like. So there can be a feedback loop. The better you draw, the better you understand, and vice versa. It's a very important tool. The other reason that this is important is communication. So if you need to communicate with a classmate, for example, about what the figure for a problem looks like, being able to draw what you're visualizing is a key tool for that purpose. And of course, arguably, depends on how you look at it, maybe even more importantly, it's very important to be able to communicate on an exam what it is that you understand about what the figure looks like, and about, therefore, what the geometric interpretation of the question is. So it's a big deal. Okay, so some broad points before we get into specific bits of advice. For one thing, we're not going to be doing perspective drawing in this context. It's quite a bit harder to do that, and certainly to do it well. And in many cases, it's just not necessary. Now, this talk is going to focus around the kind of drawing that's important in a multivariable calculus course. And in that context, it's usually just not necessary to do perspective drawing. Okay. Also, don't set the bar too high. We're not looking to make a work of art here. We're not looking to make something that's photorealistic, or the kind of figure that you would see in a textbook, with shading and really colors and wonderful qualities that are precision and everything. Not our goal here. What we're interested in doing is talking about how to make figures that are sufficiently decent to communicate understanding and to help you as a student solve problems. It's a much lower bar. Okay. So we're going to do something called line drawing. It's a very simple way to draw. It's centered around the idea of literally just drawing curves with a pencil or pen or stylus, what have you. And it's really full of a bunch of tricks that will play on the viewer's psychology, or even your own psychology. We'll say to fool the eye, but your psychology, your brain will look at things that you've done with simple line drawings and infer that things are there when they aren't. So that's one of the things that we're going to talk about in a few moments. There are, of course, some tools that are very useful in trying to make decent drawings. So a straight edge, for example, very convenient to have a straight edge, so you can draw these perfect straight lines instead of kind of wambly, wiggly lines, and this is doesn't work as well. You also might consider using a compass for drawing nicer circles. And this can make a difference in the quality of your drawings. Now, of course, what you do on the homework is almost certainly entirely up to you. The question is whether you can bring them in to exams, and you may be. It's entirely possible, very likely, I think, that your instructor would be okay with you bringing in a straight edge and or a compass into the exams. I emphasize, though, you do have to ask your instructor whether they will allow that. Okay. So another thing to keep in mind, don't aim for perfection with your first drawing. Sometimes you have to make a series of figures. And every time you draw something, you learn a little bit more about what the thing looks like that you're trying to draw, and what's more effective in representing that. And after you've made a figure, you learn from that figure a little bit more. You have a clearer picture of what you want to do, and then the next figure that you draw can be better. Okay, so sometimes you might have to make a series of several figures in a row that will eventually converge on a good figure. Okay, the last broad point, and this is a big one, make sure to practice. These are skills. It is not sufficient simply to understand the techniques. that we're going to talk about here in the abstract. You have to make your hand, your fingers, capable of actually producing these kinds of results. So it does take practice, time, and effort to make this work out well. So it's one thing to acquire sort of a certain functional level of competence in being able to do it, but that doesn't stop there. You can hone these skills and get better and better to the point that your figures can actually be, pretty decent. Okay. All right. So let's talk about some specific skills. First example I want to talk about, and this is sort of an obvious one, I suppose, but basic geometric features. Be careful, right? Pay attention to obvious points. So, for example, if you're talking about a straight line, if you're trying to represent a straight line, represent your straight line with a line that is reasonably straight. Right? Likewise, if you want to make a vertical line, make sure it looks reasonably vertical, and likewise, horizontal should be horizontal. This can make a big difference. So, silly example here, but let's look at these two attempts at drawing a rectangle in the XY plane, and obviously this one is terribly bad, but let's point specifically to what is it that's bad about this. Well, that is supposed to be a straight line. That's the y-axis. It's not even close to actually straight, though, in what I've drawn. Likewise, that's not straight. This is supposed to be a horizontal line. I didn't draw it even close to horizontally. Right? Likewise, this is bad in the different direction. There's all sorts of things about here that violate these very simple rules right here, thus ending in a bad picture. And notice that if I straighten those things out, right, these lines are all straight now. Makes a big difference right away. Notice that if the vertical lines are all vertical, your eye tends to notice that, and you pick up. Again, this is the psychology. You notice that this was drawn vertically, and your mind then infers that what you're supposed to be visualizing from this is vertical. Okay. All right. Next point, and this is again, a basic geometric feature to just pay attention to. Things that are parallel should look parallel when you draw them. Now, again, very important point, we're not doing perspective drawing here. In perspective drawing, parallel lines, meet at infinity, which is a point on the page, and we're not going to be doing that kind of thing. In this kind of much simpler drawing that we're going to be doing here, parallel lines should look parallel. So let's look at this figure here. Now, at a glance, if you just look at this cube as drawn here, box, whatever that is, at a glance it doesn't look horrible, but there's just kind of something about this picture here that just doesn't seem quite right. It sort of seems maybe like this box has been sort of twisted, sort of turned around a vertical axis. It's maybe going around too much that way or something. And this is actually pretty recognizably the effect of a certain kind of a blunder, and that is that these lines here, they're all parallel to each other. That contributes to this actually looking nice on its own, right? But in terms of how that fits with the XYZ axes, in particular, those should have been parallel to this. And notice they just aren't. Right? This is a bad representation because those are simply not drawn parallel. Not even very close. So, easily fixed though. Now notice here, I've just kind of straightened that out a little bit. These edges all parallel to each other. Again, this cube looks pretty decent on its own, but furthermore, it actually looks good now in the overall picture because those do look reasonably close, good enough to being parallel. Okay, so we get a better overall result. So do keep that in mind. This is a surprisingly big point. Think about what is it in your picture, what is it in what you're trying to represent that should be parallel, and then make a conscious effort to make sure that when you draw them, that you actually draw them parallel. Okay. All right. A subtler trick. If you have a line that is sort of behind a face of something that you're drawing. You might dot that line. So, for example, let's look at this cube right here. Now, arguably that's a pretty decent cube. Everything is parallel, looks parallel, etc. It's reasonably good work there. But you could argue that it's kind of hard to tell, as I've drawn it here, whether this is in the front and this is in the back there, or vice versa, right? Maybe this is in the front and this is in the back. And as it's drawn, it's not really immediately clear which one that is. So the dotted lines can help communicate this. So you'll notice here that I've got this line here drawn as dotted. The idea there is that there is a face in front. There, this face is kind of in front. It's as if that face is obscuring that back edge. And likewise, there's another face here that's in front of kind of the rest of that edge back there. And this edge then is just somewhat obscured. And so to kind of give the appearance of it being a little obscured, we use a little dotted line. Okay, so it's just a little bit of a visual tool. Again, it's a little bit more clear what this is than what this is. All right. By the way, notice in this what we're doing here, we have here a cube. This cube is made up of vertices and edges and faces. We draw the edges. And this is just a matter of sort of realism. I can't really draw the faces. If I were to draw the entire face, drawing this face, well, it's a two-dimensional face, and I have a one-dimensional stylus, pencil, pen, what have you. If I were to draw that whole face, and if I were to draw this whole face, etc., draw that whole face, we'd just end up with a big blob of black. Right? It just doesn't make any sense to actually draw the faces themselves. So we tend to draw the edges, and then we sort of infer the faces. So again, with the psychology, we didn't actually draw that surface there, but by virtue of having drawn the edges that surround that surface, your eye infers that it's there. Okay. All right. How do you draw a plane? It's hard to draw a plane perfectly. Now again, a plane is a surface. You can't draw all the points in the plane. If you were to draw all the points in the plane, you'd just have a big blob. The other problem with a plane, that being a full plane, is that it extends to infinity. And you can't draw something that goes infinitely in all directions. So, again, we have finite paper. So how do we deal with this? Well, what we tend to do is we tend to draw a rectangle inside of that plane. So, for example, this is not actually the plane. The plane, the actual plane, extends infinitely in all directions. Right? So what I've drawn here is just a rectangle that's sitting inside of that plane. And then the eye infers that, oh, okay, well, if this is a rectangle inside of the plane, then I can draw certain conclusions based on what it is that I'm seeing. So, for example, this angle right there, you notice as I've drawn it, it's not exactly 90 degrees. I mean, this, if you look on the piece of paper here, that angle is less than 90 degrees. But given that we're assuming that this is a rectangle, that means that we must be looking sort of edge on at this angle, and thus we infer that this plane is sort of leaning back on the upper side, and then maybe kind of leaning forward here on the underside. And we achieve that by virtue of that angle right there. Okay. Related, here's another plane. Notice that this plane appears to be horizontal. How did I do that? How did I make it look like this plane is horizontal. And again, this is a psychology trick. Whether you consciously noticed it or not, on some level, you probably noticed that those lines there are parallel. They're drawn parallel. So your mind is inferring that because they're drawn parallel, then I must be trying to represent things which are in fact parallel. And that is what causes you to feel like you're seeing something that's parallel to the x-axis. Likewise, that, and that are all drawn parallel, and therefore your mind is inferring that they must, what I'm trying to represent with this figure must actually be parallel. And therefore this plane comes off looking parallel to the xy plane. Thus it comes off looking horizontal. So it's a nice trick, something to keep in mind. And again, this goes back to this earlier point. Think always very carefully about what's supposed to be parallel to what, and then draw it accordingly. Okay. Right. Okay. Getting into smaller tricks, sometimes it can help to bold a point. Put a little bold dot down there, just as a way of noting that a couple of things are actually intersecting. So, for example, you look at this figure that I have here, and you can tell that I'm drawing a couple of lines, but based on how it's drawn, I mean, how do you know if maybe this line is in the front and this line could be sort of in the back underneath it, right? Or maybe this line is in the front and this line is sort of in the back underneath it. And based on what I've drawn here, you can't really tell. And I suppose a third possibility is maybe, again, you just can't tell from what's drawn here, maybe they're actually intersecting at that point. Well, you can remove this ambiguity if you just put down a dot there. Now, this dot, why is it that your eye sort of therefore infers that these lines intersect? Well, the dot, putting a nice bold dot right there, kind of tells your mind that this point is a point of significance. And if you put a dot there, that means that this means something. If one of these lines were in front of or behind the other, then there would actually not be a point of significance there. So putting the dot helps the viewer infer that these lines actually intersect. Okay. A couple other examples. How would you infer from what's drawn over here that this line and this plane intersect if there were no dot there? Right? It's not clear what's going on, and that dot really helps the eye infer that that's the point that those things intersect. Another example. Here I've drawn a plane. Now this is a different way to draw a plane. We talked a few pages back about drawing planes by drawing rectangles inside of the planes, such as what I did here. But over here in this example, I didn't do that. What I've done is I've represented this plane by drawing a triangle inside the plane. And the reason I'm drawing that triangle is because these points are points of significance. I'm drawing on the picture the three intersections of this plane with the coordinate axes. Right? So this point is where we intersect with the x-axis. And this point is where we intersect with the y-axis. And this point is where our plane intersects with the z-axis. And that helps us visualize, what's going on. How is this plane here oriented? Seeing how it intersects those coordinate axes helps. Okay. All right. So another thing that we draw when we want to represent something, not edges, we draw things called horizon lines. So horizon lines, so nothing is really on the surface, nothing is actually happening on a horizon line. It's just how you perceive the item in question. So for example, let's look at this paraboloid here. And you can kind of visualize that that is a paraboloid. Well, there's two sort of things that are happening here. On the one hand, there are some edges. Specifically, this is the edge. This is where And depending on what I'm looking at here, this is, you might say, where the surface kind of ends, right? The paraboloid is coming up and it sort of stops right there on that edge. So I draw that edge because something's happening there. But that's not what I'm doing here. That's not an edge. What we have there is the surface is kind of going around. It's a round paraboloid. And that's where the surface, at least from the perspective of, where I'm looking at it here, that's where it sort of wraps behind itself. So nothing's actually happening there. That's just where I'm viewing the surface as doing something, namely going behind itself. So I'll call it a horizon line. It makes sense from common usage of the word horizon. And it distinguishes directions from your point of view where you are hitting the surface from directions from your point of view where you're not hitting the surface, you might say. Okay, so for curved surfaces in particular, drawing horizon lines is a big deal. So this is a horizon line. This is an edge. Okay. So that's a tool that you have to keep in mind when you're drawing curved surfaces. Here's another example. Here's a curved surface. This is a hyperboloid. If you've gotten that far into a multivariable calculus class, hyperboloid. Now, so again, this is a horizon line. So there's nothing actually happening there. It's not an edge. That's just where the surface appears to kind of disappear behind itself, whereas edges are there and there. Okay. All right, notice that this edge is sort of behind this part of the surface. And so again, I'm drawing it as dotted to indicate the fact that it's somewhat obscured, and thus helping you realize that this is in the back of the surface. Okay. Okay. A couple more little tricks. So sometimes it can be useful to add a belt. So it's a silly example, but suppose that were how we're going to draw a sphere. This is arguably how one would draw the sphere, given the tools that we've talked about. Specifically, there's the horizon line. Looking at this sphere from some distance away. There aren't any edges. What edges would I draw? And so drawing only horizon lines and edges, you would get this. And the problem, of course, with this picture is that this picture, it just looks like a circle. How can I see the thickness? How can I see the dimension of the sphere that we're trying to draw here? So a good way to do that, again, is with the belt. So there's that horizon line that we did previously. But now if you add this belt around it, right, note that this result, it's very clearly three-dimensional. This pops in your mind as being a sphere living in 3 dimensions, whereas this picture here, it just looks like a circle in 2 dimensions. Okay. All right. Just as another example, that thing right there looks like just a curve, but if I put a little belt around it, right now it looks like a solid, or at least a surface in space. That little belt adding dimension. Okay. All right. So these are a lot of tools, a lot of tricks to keep in mind, lots of little ways to take advantage of the psychology of how our mind infers things from things that are written on the page to try to induce images to appear in your mind, right? So that's kind of what drawing is. And with these tricks, you can do a lot of things. That said, don't want to reinvent the wheel every time you need to make a figure. So common shapes, things that you feel like you're going to be drawing a lot of, such as these examples that I had here. Practice those. right? So practice drawing paraboloids, practice drawing hyperboloids, spheres, ellipsoids, rectangular boxes, things like that. Don't get yourself into a situation like an exam where you need to be able to do these sorts of things, and let that be your first time drawing such a figure. It'll be harder. If you've practiced different versions of it, it'll be easier. So these in particular, think about how you would turn these in different directions, like maybe put that axis over this way. How would you draw a paraboloid coming out of the page? Or how would you draw a paraboloid if the axis were over that way? And so, practice these kinds of things. There's a paraboloid with its axis going to the right. Here's a paraboloid with its axis coming out of the page, etc. Okay, so this recording was just to communicate basic tricks of how to do drawings. The next recording will show some hard examples of how to draw, challenging figures, or how we're going to use the tricks that we've talked about in this recording to actually do a decent job of drawing those challenging figures. So please watch the next recording in this series.